All right, so let's moving on. What are we gonna do next? We can do. We can now gonna do the next part of the Newtonian mechanics, and that is, remember, we stop right here. Now we're gonna do the next part, and we start with the momentum. So P is momentum, and momentum is, you know, mass times velocity. So what question we can come with? Let's say a truck, a 10 kg cart moving at 20 meter per second. Find momentum. Okay, so let's see. P equal 10 kg cart and velocity is 20 meter per second, and that is 200 kilogram meter per second. All right, so that's what it is. That's the momentum. What about okay, what about the angular momentum or other kind of crazy momentum? We also will be able to find that kind of that kind of momentum. Maybe we should do that. The example would be the torque. Maybe torque, which is a vector quantity. So vector quantity, one way of vector quantity can express using the cross product. So this is only for, just for advanced student. So we're gonna do that. So this is a vector quantity. So let's have a 3D. All right. So this is a 3D. This is our x. This is our y. This is our z. And we have a r here, okay? So we have a r here, okay? So let's make a question to calculate the torque. Calculate the torque. So suppose let's write here. Suppose vector r is in a z and x plane, is in z and x plane. All right. So a plane has a 3D, and this is a 3D. How we even visualize 3D? So this is a 3D. Okay. So there is something like this. So here my pencil is x. Here my pencil is x. And the chalk there on the vertical direction, that is y, and the chalk in the horizontal direction, that is z. All right, so this is a plane which has a 3D, okay? So suppose vector r is in a zx plane, and the r has a 2 component, 1.2 I plus 1.2 k. Calculate its torque if the force is 150 Newton, which is in I guess, or we can make it z. All right. So okay, so this is torque. Well, torque is something like that. This is force times cross product R, which is oh god, maybe a frog inside my neck, I guess. This is ginger ale, I guess. I hope it will help. So I, J, K, all right. So well, let's see. Why I? What is they? What is k? This is engineering notation. We call this is I, this is they, and this is k. Okay. Alright, so if you don't understand cross product, you want to watch my math videos, especially the linear algebra videos, then it would be clear. But let's do it. Okay, so what is the force? What is the? Let's write R first. R force. Okay, so R is 1.2I, 1.2I, 1.2K. So Z is 0, 1.2K. All right. So force is 1.5, 150, I 0, 0. Okay. So that's how the cross product works. Let's do it together. All right. So this guy and this guy, 0 times 0 is 0. Minus 0 times this one is 0 I, I, yeah, plus, now we're going to do, okay, we did this one, now we're going to do this one and this one, okay. So this is also 0 minus 0, I guess this is j, and finally we have a k, this one and this one, so this one is 0, and then this one 1.50 times 1.2, 1.50 times 1.2, which is 1.8, so 1.8. So our torque is just simply 1.8. Yeah, so our torque is 1.8, right? So this is kind of a little bit more interesting, kind of you know, momentum, rotational momentum, you know, inertial momentum. Inertial momentum can express using the torque formula. We'll do it more and more, but let's get the simple thing done first. Okay, so we finish the momentum, and we also understand a little bit of angular momentum and a little bit of torque. So we finish that. Now let's do this one, number 14. PB equal PA. What is that? PB equal PA. So this is like momentum before equal to momentum after. So let's make a question. Let's make a question. Okay. So this is where you can try to understand the elasticity. What is well, let's try to make a question first. Two cart. A cart, maybe a cart. Cart A, maybe cart A of mass 5 kg moves 5 meter per second, collide with cart B, mass cart B with mass 2 kg moves 2 meters per second. After the collision, after the collision, cart B moves 4 meters per second. Find velocity of car A after collision. Okay, so like let's understand the elasticity now. Okay, so elasticity, let's say this is car A, car B, right? Right. So now they're gonna collide each other. So this is car A and this is car B. Due to the collision, they're gonna go this way and they're gonna go this way, and this is elastic. If they don't go far, all right, if they don't go far, then it is not elastic. So after answering this question, we'll also try to understand whether the car A and B are elastic or not elastic. Let's see. Let's write this formula in a more sophisticated way. Let's see. Mass of car A times velocity of car A plus mass of car B times the velocity of car B before the collision. After the collision is mass of car A times mass of car, acceleration, velocity of car A plus mass of car B, velocity of car B. All right, okay. What we try to find, that's we're gonna highlight. After the collision, what was the velocity of car A, right? So we're gonna isolate that guy. How are we gonna isolate that guy? Let's see, we're gonna bring those formula this side. So m prime of A is equal to, simply, this one gonna go downstairs, m prime, let's say B prime of A, velocity B prime of A. So m prime of A, alright, so m prime means the velocity of the cart, no, the mass of the cart after the collision. Okay, so mass of the cart after the collision is same. Now let's see. This is already there. So mass of A, velocity of A plus mass of B, velocity of B, velocity of B, velocity of B. All right, minus mass of B, velocity of B. Okay. So what is the mass of A after the collision? Is same thing. Mass is always same, right? Kg. Right? Mass of A, velocity of A, mass of A is 5 kg all the time, and velocity is 5 meter per second, plus mass of B is 2 kg and 2 meter per second, minus, what is the mass of B after collision? Same, 2 kg, 2 kg, but velocity of B after the collision is 4 meter per second. Okay, 2 kg, mass is always same, the velocity is 4 meter per second. Okay, so this is my velocity. All right, so let's see. Now it's simple. So velocity of A after the collision is, let's see. 25 kg meter per second plus 4 kg meter per second minus 28 kg meter per second. All right. So 25 and 4, 29, 8, 21. So 21 kg meter per second and 5 kg. Kg cancel, 5 goes to 21, 4 times 4.2. So velocity of car A after the collision is simply 4.2 meter per second. Now, is this a okay? So velocity of B after the collision is 4 meter per second, and velocity of A after the collision is 4.2 meter per second. Before the collision, it was 2 meter per second and 5 meter per second. Now let's see whether it is elastic or not elastic. I guess it is elastic because the velocity of B double after the collision, and velocity of A remains somewhat same, but it is, I guess, is elastic.